let's start chapter 7. So nuts up, please. Hey. You're good. I'll mark you. Remind me in a second. I'll put it right here. This will tell me. Perfect. Okay. Okay. So we are going to continue with our normal curve. And what this chapter is going to talk about is confidence intervals. So how confident we are if we were to resubmit data. Okay? So this chapter, last chapter, chapter before, I'm not going to write the whole thing, but basically, as far as this information goes, within one standard deviation, you have 68% of your population. So then we changed this up to where we modified this a little bit and we modified this a little bit. Okay, because we didn't know what the standard deviation was. And so, excuse me. Sometimes we can narrow this and sometimes we can widen it depending upon, how broad our spectrum of data is. So, in statistics, the way that you accept your information is you create a hypothesis, and then you excuse me. Then you create what is called the null hypothesis. The knee-jerk reactions that are taking place in society don't do this. And it's bad, and it shouldn't be accepted. And the reason why they do it is because there's financial gain for a knee-jerk reaction. So a lot of times people say, hey, look what this data is. This is how we're going to start doing stuff. And then you... excuse me, someone's stuck with me. But the problem is, if you don't have a hypothesis, you don't have a null, and you're collecting just data, why? So a hypothesis means you're going to make some sort of educated guess off of observations. And from those observations, you're going to test your null hypothesis. So you're testing the opposite of what your hypothesis is. And then you can either accept your null or fail to reject your null. So you're testing your null hypothesis, and then you're saying that, well, that could lead to my hypothesis if the opposite takes place. So, again, the problem with doing these the correct way is it costs money. And unfortunately, society as a whole is lazy. And the people who are collecting arbitrary data and making decisions off of it realizes that society is lazy and they just want to know. Well, you just tell me. There are schools and school districts out there that are pretty much broke. They can't afford to stay open. They're getting nice amounts of money from the state in order to pay their staff, in order to keep the lights on, the water, all those other great things. But unfortunately, the knee-jerk reaction of some publication company came in saying, hey, you need to do this. Look at this. Look what we found. And the school goes, oh, that's really cool. Therefore, I'm going to do it. And so now they're 10, 15 years out on paying this yearly fee to this company because a knee-jerk reaction was made in order to better their school. This school and this district, the district does it some, this school doesn't. This school doesn't really change a whole heck of a lot of stuff that it does. Why? Because it works. The population we have, it works. Why don't we have block scheduling here? Yeah, we do awesome without it. Okay? I did my master's thesis based on block scheduling versus traditional. I have a 108-page, 5-chapter thesis. It's boring to read. And out of 2 years' worth of collecting information and data, the only thing that I found that's different between block scheduling and traditional is you have less unsupervised interaction amongst students with block scheduling than you do with traditional. You want to know why? How many periods are in this day? How many periods do you have over there at Cherokee Trail? So if you have 4 periods in the day, that means you have before and after school, and in between those periods that kids get to interact. So that's 5 different unsupervised interactions that take place amongst kids at some other school.
How does that fucking work?
Huh? And then, if we have 8 periods here, we have 9 different times that we have unsupervised interaction amongst kids. It's the only thing I found. And I can do statistics. But what's the knee-jerk reaction to it? Hey, if you offer block scheduling, look at this. You get kids for a longer period of time. You know how much it sucks as a student to sit in a class for 90 minutes? It's horrible. You know how much it sucks to teach for 90 minutes? Because you're like, oh yeah, it should be easy. You should be able to teach at least 2 lessons in 90 minutes. No. But it was a big knee-jerk reaction going, oh, look at this. And schools jumped to it saying, oh, this is going to be awesome. Now, I think I'm an okay teacher. I think I have some sarcasm that makes you chuckle from time to time. So I don't know if I have the most difficult class to stay in for a long period of time. But let's say you're really a bad math student. Could you imagine sitting in math for 90 full minutes? Going, oh my, he won't shut up. And then the teacher then says, oh, this is awesome. I can give you a 90-minute test. Oh, horrible. So, knee-jerk reactions and statistics are really bad. And they cost a lot. So, chapter 7, 7.1 talks about confidence intervals. So a few things. So if I sample 25 adults, that means you have n equals 25. Where did the 25 come from? Well, we sampled 25 people. Okay? And then it says, a recent study found out on average an adult consumes 27.9 ounces of coffee per day, plus or minus 2 ounces. So, some data collection took place. They found that people were drinking about this much coffee. But then they tell us that within plus or minus 2 ounces, our study is going to take place. Hey, thanks. Okay.
Thank you.
There's a sticker on it that says, "You are not in trouble." That's good. Okay, so what this means is on this normal curve, so this could go up to 29.9, this could go to 25.9. So in our data collection, we found that we had a certain amount of people that drank coffee. We averaged 27.9. Each time we collected the cup, we realized we were within 2 ounces of the 27.9 ounces that people had consumed. Okay, so we estimate versus interval estimate, 2 different things. We can be more confident the interval. Okay, so hang on, wait, let's make this work. So this is kind of a, when we do this study, you have this area that we're talking about. And if I walked around and everybody here was drinking coffee, which I know you don't, but let's pretend we were all coffee drinkers. If I went around and I asked you to keep track of how much coffee you drank throughout the day as far as ounces went, between 25.9 and 29.9 ounces would have been drank that we would find. Okay? Now, we could say that if we were to redo this study by doing the exact same thing, we're still going to find that within 2 ounces, people drank that much coffee per day. Okay? So now we're going to start predicting, and we got a confidence interval. So CI, confidence interval, is X bar, so the average, plus or minus E, where that's our margin of error. Okay? And E is defined to you as this. Okay? Z is our Z-score, which could be the same thing as your standard deviation with decimal amounts. Okay? This is our population. And what is N? That's the number of people. So in this case, it would be 25, the number of people we surveyed. So a recent study found that on average, an adult, our population, our adults, our N is the number of people we surveyed in order to get there. Okay? The critical value, Z, is based on your confidence level. So let's go a little bit further. So we're going to fill this table, and I'm going to show you how this all came out. Okay. Let's see if I can make this work. If I were to say to you, I know that if I redid this coffee study, I know that I am 99% confident that our results are going to happen to be between the plus or minus 2 ounces of the 27.9. So what you think about it is this. Is this a large area in comparison to this? Let's do this one, blue. Am I more confident that the blue region is going to happen or the red? I'm more confident that the red's going to happen. And I'm more confident because I'm going to create a margin of error that's a larger amount. Okay? Let's say we look at all of the prop stats classes that have ever been taught here at CC. We could say that with 90% confidence, all grades, if the average grade is 68%, we could say with 99% accuracy versus 90% accuracy, 99% would be a huge area that our grades fall within plus or minus 25 points or 25% of 68%. If I said with 90% confidence, I have a smaller region. So if I want to be confident about what I say, as confident as I can, I'm going to take a larger area. Hang on, I got to sneeze. It's going to come out. Excuse me. Hang on, one more. All clear. Okay. So let me see if I can make this work. I collect data. Yes? Abby, if you want to talk all period, find your way out in the hall. Hey, not going to debate you. Start pointing at other people. Okay. If I want to go and collect data, I know Lenny wouldn't be talking. So, yeah, That kid. Next, you're going to start playing with matches. Matches. Striking worst. Okay, let's see if I can make. I got to make this work. A confidence interval is going to work this way. If I was going to use, let's go with a 95th percentile confidence interval. I would phrase it this way. If I had collected data, I had created a hypothesis and a null hypothesis, I collected data, and it showed me an average of something, I would be able to say with 95% certainty, if I duplicated my act of collecting data by using the same type of questions, by using the same kind of data collection, and using about the same population, I feel 95% confident that my data would fall within this region again. Okay, so let's go. I collected data to find out. Let's go to the hypothesis. Block scheduling has a positive effect on math classes. So my null hypothesis, block scheduling does not have a positive effect on math classes. Okay, so I'm going to test the null. I'm going to go nationwide to every school, and I am going to give every school a certain pre-test and a certain post-test. So let's say I want to test Algebra 1. Okay, so I'm going to create a pre-test for Algebra 1 that every kid, or that any kid could be subjected to taking this pre-test. Now, if I want to tighten this up a little bit further, what I'm going to do is I have every high school USA. Okay, whether it's traditional, whether it's on block, whether it is a charter school, a private school, it doesn't matter. But one of those schools are going to fall under some sort of category. They're going to either have full block, modified block, or traditional. Modified block means you have Monday, Tuesday, Wednesday would be like we have here, and then Thursday, Friday, you'd only have half your classes for twice the length. Or some sort of version of that. So then I have to realize I have this category that I have done. So I have traditional scheduling, I have block scheduling, and then there's some sort of modified that's a combination of block and traditional. Okay, still following me on this scenario. Let's put an arbitrary value. Let's say that we have looked up high schools in the United States, and we have found that between the private, the public, charters, that there's 50,000 high schools USA. And I'm just making that up, but let's just pretend we found that information. Is that okay so far? So now what I'm going to do is of those 50,000 schools, I'm going to label the very first school this, and the very last school this. And I'm going to create using a random number generator to assign the schools. Okay, so if I use a random number generator to assign the schools, I'm then going to say, okay, I don't want to set a pretest to all 50,000 schools. That's called a census. Okay, but what I'm going to do is I'm going to select 100 high schools to randomly pick throughout the United States. So I'm going to pick 100 high schools. Okay, I'm going to use my random number generator. I'm going to look at the first, line 64 of my random table in the back of the book, or I'm going to use a random number generator on the calculator. I'm going to figure out how I'm going to select these 100 schools. It's going to be a random selection. Of those random schools, let's say I want to isolate down one Algebra 1 section per school. So now I'm going to select one Algebra 1 section, and I'm going to hand out to those 100 schools, I want of this, I'm going to tell the schools, I need you to choose for me in one Algebra 1 section, which was chosen randomly. I want you to pick 5 students randomly. So 5 students are going to have this pretest per every 100 school that I pick. And so let's say then I give the pretest, they send it back to me. I then keep tabs on those schools, and then I give a post-test at the end. Uh-oh, too many people with their heads down. Theoretically, how many pretests have then gone out? How much? I'm picking 100 different high schools at random. 5 pretests per those schools go out. How many pretests supposedly have gone out? 500. Okay? So what I then did is I create a letter that goes out to these particular teachers saying, look at your alphabetized list of students, and I want you to pick the 7th, the 12th, the 19th, the 26th, and the 4th student off your list. And how I came up with those numbers, I just chose my random number generator. So if you're that teacher and you look at your roster, and let's say you want to participate in this, you don't know. Do I really get all 500 pretests back? No. What do most people do? Especially teachers. We get stuff in our mailbox all the time. There's a recycle bin that's right there. Why? Yeah, it's like, doesn't look important, doesn't look important, doesn't look important. And that's how stuff goes. So, will there truly be 500 pretests that are given out there? No. We're lucky if like 100 are actually given. And then the post-test of those 100, I'm lucky if I get like 30 of them back. Why is that? People are busy. They're not willing to do it. Teachers are lazy. Sure, I'll go with that. Okay? Now, but as a teacher, there's a form that I get about every month. It comes in a official-looking UPS envelope. Okay, because I teach a medical careers class, I'm on a list. And this thing has about 30 applications in there, and they want me to do this. They want me to figure out 30 of my students, send back the student's name, address, and phone number. You know what would happen if I did that? I'd be fired. And I'd be sued. I do not have the right to give out your information to anybody. That's what I can't figure out. And of the past 8 years that I've done the med class, this same thing comes my way. Hey, just send us the student's first name, first and last name, their address, and their phone number for this information. No. And then the counselors get the same thing if the school has medical class. Then I get all the counselors putting them in my mailbox. And I'll go to the counselors going, look, I can't give this information out, nor can you. Oh, I know, but I thought you could use it. To put it in the recycle bin? Yes. Recycle it. I'm not giving anyone's information out. It's illegal. but they're trying to solicit this information. So, let's say those 50,000 high schools, I selected 100 high schools at random. I send out 500 pre-tests in which each of those high schools will get 5 pre-tests and they get directions in order to collect this data. I then send out the same thing at the end of the year saying, here's the post-test. I collect all the information I can back, and then I make a judgment call whether to fail to reject the null or accept the null hypothesis. I then have a baseline of information. So the following year, I'm going to be involved in the same exact fun activity as doing this. But what I can do is I can say, within 90%, I am 90% certain that if I redid this test the same way, looking at 50,000 high schools across America, selecting 100 at random, of those 100, sending 5 pre-tests to Algebra 1 teachers that are picked at random, then I am 90% confident that my results will fall within here again. Okay? If I wanted to do 95% confident, then this is going to be a larger region. If I wanted to go 99% confident, it's an even bigger region. So I am creating a scenario where I feel that I'm confident that if I collect the data the same way by asking the same questions, by doing all this, that my data would fall inside this region again. So your z-score, these should be filled in on your table, and I don't have it's 7.1 first page. Okay? And then there's terms that you need to know, like SRS. This is a simple random sample. Now, I don't care if this seems like an exciting event or not, but what can you think might be some problems with 50,000 high schools across America sending out 5 pre-tests to Algebra 1 students to a randomly selected teacher in that school that teaches Algebra 1? Do you think my salary is going to cover that for many years? No. On that right board, that's expensive. Creating simple random samples is tough. Okay? Going to the mall and standing outside of the JCPenney entrance or whatever entrance you use, if you're that person with the clipboard and you're trying to make eye contact with every person coming in and out saying, oh, hi, are you a registered voter? I'm always a no. Because the interview is now over. Am I really a registered voter? Yes. When the person comes up to me with the clipboard, hi, you a registered voter? No. Okay. Why is that? I don't want to be bothered by it. Why is that? Because I'm going to the mall to get something. I'm not going to go to the mall and say, oh, how do I feel about, beating puppies? It doesn't mean anything to me. I don't feel like giving my information. I'm busy. Am I the only person that doesn't talk to the people at the JCPenney outlet? Heck no. You see that guy sitting there with a clipboard going like this? I might take the longer entrance in so I don't even have to deal with them. Why? Because I'm busy. And you all are busy. So that's a really bad way of selecting data. Okay, what's another good way of collecting data? Oh, geez, maybe I mail stuff out to people, and I get very little back. I got a great thing a couple years ago.
Oh, I was just going to say maybe mail it out there to only people that want to respond.
Ooh, that brings up a little problem there, because everyone who wants to respond.
We feel one side of their argument.
Denver Post likes to do surveys. CNN likes to do surveys. Oh, I was watching it the other night, though I love his show. He's on Fox. Oh, shoot. What's his name? Oh, my gosh. How did I just lose his name? He's on 6 o'clock on Fox. Very Republican guy. Gosh, I can't remember his name. So he had a news talk show, and he will often ask his audience, "Hey, I want you to weigh in on this," and then you call in and you do it. Now, there you go. There you go. I like it. So if you're already watching, you're already conservative. You are volunteering to call in. Is it a good way of collecting data? No, but he'll say no without a problem. Look, I had 2,319 people who called in to do the survey. And he's trying to sway people's opinion who are watching the show going, oh, he must be right. No! It's a horrible way of collecting data. You cannot make a judgment call on it. And he is finally, thank God, finally put it at the bottom saying this is not a scientific study. Because people who are already watching that show are already of that Republican mindset, which is awesome in my opinion. But it's not a good way. So kudos to him for putting it at the bottom of the screen. And he's put it in font that you can actually read. It's not that scribe that you can't see because it's so small. It says right below it, not a scientific study. Good for him for realizing that the audience is intelligent enough to realize this isn't the law of the land, though it's what we feel. All right, let's play with these examples. What time am I at? Oh, sweet, I got plenty of time to bore the heck out of you. Okay, example 1. Next page. I'll try and entertain you. I'm sorry if I'm boring you. All right, simple random sample of 49 people. N equals 49. Still with me? Where did we get that? Random sample of 49 people. In Los Angeles, showed that they worked on average of 63.1 hours. They worked 63.1 hours. It is known that the standard deviation is 7.2 hours per week. Find a 95% confidence interval. Okay? So 95% confidence, if I go back the page, 95% is 1.96. Okay, that's the number I'm going to use. So, now we want to figure out where our data is going to work. So, find hours worked. So, I'm going to use this. E is equal to Z times population over the square root of n. It's our equation we're going to go with. So now I'm going to go, Z is 1.96, because this was a labeled stat, and I'll show you how to get there in a little bit, probably tomorrow, times 7.2 over the square root of 49. If you do the math, you're going to find that your error is 2.016, which means that if I were to reduplicate this information, I'm going to get 63.1 minus 2.016. That's going to be less than 63.1, which is less than 63.1 plus 2.016. Squeeze in there. So my confidence interval if I were to duplicate this study, I know with 95% certainty that my data is going to fall in between 61.084 hours and 65.116 hours. And that's how you do your confidence interval. Okay? So that was with 95%. The next one's going to talk about 99%. So 99%, this number is a larger number. So this is example 1. Here's example 2. It says IQ scores have been known to be a standard deviation of 15 points. If a sample of 45 students find that they have an average IQ of 108, construct a 99% confidence interval in order for us to do this. So we have a standard deviation of 15. We know our average is 108, and we have a population n equals, how many people were we testing? 45? Okay, so my z-score that I'm going to use, I'm going to flip back a page, 99%, I'm going to use 2.576, and I'm going to use this equation in order to figure out my confidence interval. So I get E is equal to 2.576 times 15 over the square root of 45. And if I do this, that's going to give me 5.75 or 758. So plus or minus. So I'm going to take this and I'm going to add 5.758 to it, and I'm going to subtract 5.758 from it. And that's going to give me 102.242, comma 113.758. If I were to duplicate my survey of the IQ, I know with 99% certainty that my data will fall between 102.242 and 113.758 if I duplicate it using the same manner. If I change a question or I change how I'm collecting the data, I cannot use this, so I have to be collecting the same way each and every time. So a lot of it has to do with your confidence interval that you're creating. So here's your confidence interval, here's your confidence interval, and that's what you're creating on each of these problems. And you're using the equation E equals Z times standard deviation over the square root of the sample. I want you to try 7.1. I want you to try it for points. Okay? Does try mean 100% complete? No, try it. I mean, try could be just labeling X bar, standard deviation, and your confidence. That could be enough try. And I think I can get you through this. And my point on all of this, guys and girls, is we as a society are lazy. We're not willing to do the hard stuff. So we are willing to accept, a lot of times, raw data and made a decision off of raw data, which is a horrible way to go through stuff. Okay? That's all I got for you. You got like 10 minutes